In this video, we're going to learn about insulators and conductors and how to identify whether a substance is an insulator or a conductor. Sometimes we wear clothes that are made of different materials, like wearing wool and cotton at the same time. These different fabrics will rub against each other and will become charged with static electricity. This especially happens during the winter months. You might notice you're putting on a fleece sweater, pull it over your head, and then once you do that, your hair is all standing up on end. And that's because the static charges remain in place where the materials rub together, because each of those things are electrical insulators. An insulator is a substance that does not allow electricity or electrons to flow freely through it. Instead, you'll end up with static charges building up on the object. So an example would be when you're cleaning or polishing a glass mirror or a piece of furniture, you're actually building up charges because you're rubbing the surface with your cloth and causing static charges to build up, and that'll actually attract dust particles to the object. So the question is, are insulators good or bad? So static electricity can be a problem and even dangerous. You can build up a static charge if you got in and out of your car while you were refueling your car, and could actually cause an explosion when you go back and touch the gas nozzle. That's bad. But some insulators are very useful because we actually use them to protect us from electric shocks. So we coat wire with plastic or rubber to protect us from being electrocuted from our electrical wiring. So some examples of insulators would be glass, so not the liquid in the glass, but the glass itself, plastic, rubber, and then wood are all examples of insulators, and there are many more examples as well that you'll be learning as we learn about the electrostatic series. Now, conductors are different. It doesn't matter how hard or how much you polish a metal tap, it never builds up a static charge. You don't see a bunch of dust particles sticking to your metal taps. And this is because metals are electrical conductors. Conductors are substances that will allow electrons to move freely from atom to atom within the substance. So those electrons move freely through the entire conductor or the entire substance. Conductors are very useful for electrical wiring because they allow electricity to be quickly transmitted along the wire. So again, here's our example of a piece of wire. The plastic coating would be the insulator, and the wire, the copper underneath, would be the conductor. Examples of conductors would be the wires in this picture. The human body is a conductor. Metals, so the coins on the ground in this picture would be examples of conductor. The car would be a conductor because it's made of metal, and then water is a conductor as well, which is why it's quite dangerous if you're swimming in a pool during a thunderstorm. You need to be evacuated because water, if lightning hit it, would actually transmit the electric charge from the lightning bolt throughout the water and could actually kill you. So the reason why static electricity is so much worse during the winter than at other times during the year is that winter air is much drier and contains fewer water molecules. So because it can hold fewer water molecules, there isn't a way to disperse that static charge. So dry air actually acts as an insulator. And at other times during the year, there's more water particles in the air, and these molecules will pick up and conduct the electric charges easily, so the charges won't build up on objects. So like we said at the beginning, if you don't have a lot of water particles in the air, you will build up static charges, and then your hair is going to stand on end if you put a wool sweater over your head. One way to get rid of those built up static charges is to wet your hair or spray a little bit of water on the substance that's got a lot of buildup of static charges.